All right, let's get back to it. Last time we had, we finished up problem 15 and had started in on problem 16 of Advent of Code 2022. The basic idea is that we are in a volcano. We have 30 minutes before the volcano erupts. We have to relieve a bunch of pressure using valves, and the valves basically it takes a minute to go from one valve to one of its neighbors, and the valve has a certain amount of pressure per minute that it relieves. And so the question is, what path do we take? A series of stepping from valve to valve and opening valves, which also takes a minute. They all start closed in order to have the cumulative pressure relief be as high as possible. And so the basic approach that we decided to take was, look, if we start at the beginning, we plan out every possible trajectory, it's going to be enormous and huge and slow. That doesn't work. What we can do instead is start at the end and say, well, at minute 30, it doesn't matter what you do. Time's up. At minute 29, if you're at A and it's open, you can't do anything. If it's closed, you can do something. You can open it. Okay, you should do that. At B, same story. At C, same story. Okay. So now at the prior minute, 28, now we can evaluate what we should do from each position by looking at what happened at minute 29 and so on. And that cuts out a lot of computation because you're essentially eliminating a whole bunch of cases. You don't have to worry about a whole bunch of cases at the tail. Like when you're considering minute 15, you already know what the minute 16 optima are, and you're never computing some suboptimal minute 16 thing that goes into a suboptimal 17-minute thing, and so on and so forth. You've removed all of those computations you have to do. There's still some trickiness. Like there are a lot of different possible states for the tunnels to be in, for the valves to be in. Only some of them matter. But because there are a lot of different states that you can be in, it definitely means that there's still a fair amount of very similar computation. The good thing is, I think if we implement it this way and it's still slow, there are a lot of options. There are a lot of places to go from there as far as speeding it up. For instance, things like eliminating essentially equivalent situations would be the basic idea. So I think we have a good set of paths here, so to speak. Let's get into it. So last time we had started writing up the parser, and I think right at the end I realized that the type that I had defined for valve, we're using neighbors are going to, the way a valve is going to know its neighbors is just going to be based on the indexes of the vector that it's in. And that makes parsing, that means that you can't just parse each valve individually. Like, it matters that a valve is in amongst other valves. Because you have to know, in some sense, you have to know, if we're doing it this way, this U size, the only sense in which the U size matters is as a pointer within a vector that has a bunch of valves in it, which I actually don't like very much. It feels the type has to know things about the container that it's in. Feels bad. So I think what I want to do is change this to use the label, and then we'll have a valve container, or we'll have some outer struct that has a hash map to all of the valves. So let's take a look at our tests. So I think we actually want to say get neighbors. We want to return something like DD, and are they going to be, they have to be owned, so I think they have to be strings. II and BB. It's a little interesting to think about if we want to store these in a hash map instead, or a hash set rather, since obviously we don't tremendously care about order here. For now, a vector is fine. And we'll do something similar here. This is going to be JJ, no, II, T-string. Okay. And then in here, we're going to update usize will instead be string. String. And in here, we just need to say dot map ss2 string. Okay. And what's wrong here? Reference to a string is fine. Okay. So that should mean that the parsing is working. So, okay, so now we need to work out what we want the outer type to be. I guess we still want all these functions. Let's just implement these functions quickly. Wait, get neighbors, get flow rate. We already did implement these functions. What are we missing? Get neighbors, get pressure. Oh, it's because I've moved it. Oh, these should borrow. Oh, get flow rate is what I called it. Get pressure should be get flow rate. And what's wrong with get neighbors? It returns a reference. Okay. And now is closed, open, cumulative, get cumulative pressure from, all need to be implemented. So let's say get cumulative pressure from, and this is going to be some number of minutes. Size, sure. And this is going to be a U32. And the idea here is it's going to be till eruption minus T. T is 30, we want it to be 0. So yeah, just minus T should work. And then this whole thing times self dot flow rate. And we'll just say const. This will be a U size, and it will equal 30. Okay. And then we need open, and is open, and is closed. What's wrong with this? Found U size. We probably need, whoops. Is open will be a bool, and it will start out as false. Okay, that's great. And now pub function open will take self mutably, and it will not return anything, and it will say self that is open is true. Is open will just return self that is open, and is closed will return the inverse of that. Good stuff. Cool. Is that everything? This probably doesn't work because, yeah, we can't borrow here. We can clone it though. Okay. So this should pass. I mean, some in should in some like normative sense. Unable to open file. That seems like an easy problem to fix. Example input 16.txt. Test problem 16. Not implemented, invalid digit. Okay. So wait, why isn't this being used? Label and flow rate should be, this needs to be flow rate half. Okay. Very close to being correct. So, what to say here? Let's throw a mark in here. And let's throw a mark in here. Label parts 1. Neighbor half. Tunnels lead to valves. length -1 probably. Not quite. So that was right the first time. But then somehow when we're splitting, we're losing. How are we losing? Well, this is what the debugger is for. Let's find out. Neighbors string is what? Neighbors string is correct. We split on comma space, then surely neighbors should be correct as well. Just want to go to here, please. Now neighbors isn't here. String, whatever. Interesting. If neighbor string is correct, how can this not be? Split should give 3 elements. Doesn't tell me what neighbors is though, which is annoying. I mean, surely I'm allowed to split on a string. Alright, let's check quickly if split works the way that we expect it to. Split splits on multiple characters, and we say let neighbors string be like DDIIBB, I think, and then we want to assert that neighbors is equal to DD toString II dot toString BB dot toString. Which it is. And which one's it failing on? That's failing on this one. Okay. So the first one it does correctly, but then this one it doesn't parse well. Maybe because split and the substring doesn't exist is doing something strange. Valve. Wow. Valve versus valves. Okay. Well, this is why we have tests. Okay. So let's get rid of this. And then we'll say if neighbors string starts with S, then neighbors string equals neighbors string. We want to skip 2 characters there. And otherwise, skip 1 character. Yep. Okay, so parsing is passing. So next, we want to kind of create an environment for our algorithm to run in, which knows how to get various things. So, what to call that? What to call that? Let's say valve set, valve graph. It's kind of a valve graph, right? It's called a valve graph. Parses, and we'll say strings. Actually, it doesn't need to parse. We can just say initializes. And here we'll say the same thing to instantiate. So the idea will basically be that then we want the graph to be valve graph, new valves, and graph dot length will be 10. We want the graph to be able to look up valves quickly. So we'll want something like assert equal graph get neighbors AA. Doesn't need to be a string, and that should return DD it should return the actual valves. It should return clone here, I guess, just for the test. So it should return valves 3, valves 8, and valves 1. If I'm doing my alphanumeric math correctly. Same thing with J, should return just valves 9. And what else? So the valve graph, the point of the valve graph is going to be that it knows how to get its neighbors. We want to be able to get the state of the graph. Oh, you know what else? The valve graph should know where the current pointer is. So we should be able to say, like, assert equals graph get us, get player, get agent, get us. Say player position. And it should be 0 for player valve. Location, so location, and this will just be AA to start with. And so then, and maybe this stores time also. At least for now. And so then we want to be able to get the state of the valves in a way that that lets us like basically the states, if we can't reach a certain point by the end of the time, then it doesn't matter whether that valve is open or closed. Other than that, it's contributing to the flow rate, but it doesn't matter from the point of view of like looking up optima. I don't know if I want this to know the time, actually. I don't know if I want this to know either of those things. Now that I'm thinking about it. Because we want to work backwards, not forwards. So maybe this is all we wanted to be able to do. And I mean, it should be able to tell us whether a certain valve is open or not, just by delegating, but yes, graph is open. Like, AA should return false, and so on. Like, in fact, well, again, though, maybe we want to be, I think we want to be instantiating it with some states. Because we're going to be starting at the end and working our way backward. So But the valves are already open and closed and so on. Right, so actually, this is probably fine. We probably want to be able to say, like, graph.open AA, and then graph is open. Just say is closed, and now graph.is open. That we want to be able to do. What's the issue? Because this type is just going to let us manipulate the state of the graph. And maybe we want to have a way to update all of the open, like to open multiple to change the state quickly. That seems like a thing we care about. Graph.open all, or like open valves. BBCC DD. And this should be CC, and this should be DD. And let's just say BCCDD, right? Okay. So the graph type knows how to set its state. I guess we might also want to let it like totally update its state. Okay, we can think about that. So the algorithm is going to start by saying it's time 29. The state is we're at point A and it's open. Then we're at point B, point A, and it's closed, and so on. So I guess we also want to be able to say graph.get moves, we'll say, if we're at position AA. And since it's open here, we have no moves that matter. It's AA and it's at time 29, let's say. So this will be it's time 29, we're at position AA. The valve is open at AA. We don't have time to do anything. So technically there's a move which is walk to. I guess there are 3 moves. can, technically there's move, walk, DD, and the same thing for the others. II and BB. But in practice, none of those do anything, and we know that none of those do anything, because at time 30 it doesn't matter whether we open any valves or not. But for now, let's not mess with that here. Let's do the same thing, but at time 29 from something I haven't opened yet, like JJ, which now we should have move open or walk II are the options. Because that's what JJ can only go to II. And what else should the valve graph be able to do? It should be able to compute the flow rate, right? So it equals, well, maybe we want to do one more of these for some other time. Doesn't actually matter at what time we're at, does it? Why do I need to specify the time here? I think I don't. So then, what else should the graph be able to do? It should be able to graph.get pressure. What do I call the other one? Get cumulative pressure from. Cumulative pressure from. And let's say 30 should be 0. 29 should be, so A, B, C, and D are open. Yes. So 0, so 13 plus 2 plus 20. 28 should be this times 2. And 0 should be this times 30. Is that right, or is that off by 1 error? No, that's right. Okay. That seems pretty good. Seems useful, at least. We can work out what our moves are. And then when it comes to running the algorithm, we'll start at the end. We will start from each of the starting positions. Yeah, we're still going to need to come up with what the actual relevant state is. But let's go ahead and implement this first. So what to say here? Let's say derive. I guess we're just deriving all this same stuff, right? hash probably isn't necessary, but it's fine. So struct valve graph, and what we want is valves to be a hash map from a string to a valve. They know their neighbors. Is that it? Is that the only thing we care about? Yeah, I guess that's the only thing we care about from a data perspective. And then from an impl perspective, we have a bunch of functions we need. We need new, which is going to take valves, and it can be a vec of valve returns a self. And in here we need to work out what the hash map is, which we do by saying let mute hash map. Let mute valve map be hash map new. Do I even need hash map new? Can I do valves.clone or even iter? Actually, into iter should be fine, I think. Into iter map for each valve. What will we do with it? We will what will we do with it? We will say v.getLabel v collect as a hash map, and we let it figure out what type to make it. So that will give us what's happening here. To generic argument. Oh, I have to specify it this way. I guess that's logical. So that gets us a map from labels to itself, and then we just say valve graph valves valve map. Close. Returns a string. What's no good here? Hash map. Valve implement string. Or hash. Does string not implement hash? Can I make this that kind of string? Oh. Never mind. It's because hash doesn't know how to derive itself. Okay. Can I make it this type? I don't think I can, because if I do, it wants a lifetime parameter and so on. Yeah, okay. Okay, so that gets us the basic valve graph. Let's implement length, which is easy. Self.valves.length. Let's implement is open self string label bool, and this just says self dot valves dot get label dot toString. I guess in principle we can pass in a bad label here. So I guess this should probably be an option. Actually, do I even need this? The map val that is open. And okay, so this does have to be. Oh no, this works. Oh right, because it's already a reference. Sure. Okay. And then same thing for closed. And we can just say self dot is open label dot map b pub function open takes itself mutably, takes a label, does nothing. I guess there's a question as to whether we want to throw. I guess we do. Option nothing. Can I not have an option nothing? Oh, I can. So this can be self.valves.get label dot I guess I match some v, then I will say v dot open none, we return none. This needs to be mutable. Get mute. Okay. And we need the cumulative, get cumulative pressure from. T will be a U size. We will return a U32, and this will just be self.valves.iter.map label valve v dot get key. Why? What's the problem? Oh, v dot get cumulative pressure from T. I guess we should label this accordingly. Actually, I think values here. Values won't give this back at all, which is a little bit cleaner. A little bit cleaner. Get pressure from, and then we just sum everything up. Okay. What else? get neighbors. Right, get neighbors and is closed. These just all need to be sum. Let's just say dot wrap. That's fine. And then get neighbors and open valves. So here, I guess, let's say open valves. Use a result, and let's say labels into iter for each, or map, I guess, self.openL. And I want to get a result out of this. So okay, or is probably good. Okay, or no valve with label L. And what's the issue here? Expected enum results string found. I need to collect. So each one of those individually is going to be a result. Let's say let results be this. And oh, can we do this? Okay, or as a result, can I kick this out? No, because it's in a closure. So let's, what type is this here? Let's make it a result of a vec of nothings string, which doesn't quite work apparently. Because these are, should be like that. And now And now we just want to return results. And I just want to map it to nothing. Cool. Okay. So that's open valves, and then what was the last thing? Oh, get neighbors. Get neighbors is important. Self label, and we return a vec of valves. And this is, again though, it might fail, so it has to be an option of a vec of valves, in which case self.valves.get label.map. If it's a valve, then we say valve.get neighbors. And do iter map for each neighbor. We want to say self.valves.get n, and this we want to expect all labels should point to valid valves. And what's the issue here? Oh, we need to collect. So the issue here is what? Valves.get .map. What's the issue? Oh. The collect needs to be here. And we're close. Valve can't be built from references. Self.valves.get. So do we just clone all of these? And we're cloning all over the place. What are we actually going to do with these? Maybe we just want to pass around labels. Because when we're actually using these, we're going to be doing everything in terms of the labels anyway. valves.get. So in that case, we don't actually need to do this. And this can return a back of strings. Map.get neighbors is sufficient. And get neighbors is an option. It's to a option of a reference, but I think that's fine in general. Okay, so these are actually going to be strings. So this will be like DD II BB, and it will be a some reference this will just be okay, so we'll pass around labels. That should be fine. And then we need to implement moves and get moves. Right. So let's drive everything except default. Drive hash though. Move, and this will be open or walk. To some label. And then copy. And then what? We need get moves. Moves self, and it should return a vector of move. We need to return the if self dot. Oh, it needs also to know where current position. If self dot is open, is closed, current position. Set to match on this. Let's just expect if self dot is closed, current position, expect current position should be a valid valve label. So if it's closed, then to return should be a vec with the move open in it. Otherwise, it can be vec new. And then to return dot append self dot get neighbors current position. We can unwrap here. We already know it's good. Into iter, or maybe not even into iter, maybe just iter. And this is going to be move walk L. And this probably needs to be a reference. Oops. And what's this about? Expected mutable reference. Expected mutable reference found a normal reference. And what happens if I mutably borrow here? That works. Whoops. Probably needs to be iter mute. That's an at string. So we just dereference it, which we can't do. So we can clone it. Okay. Good stuff. Okay. Do we expect everything to pass now? Not everything, but I mean, do we expect our main test to pass? I'm not sure we do. Valve graph initializes. So where's our failure? It says 81. Why? I opened A, B, C, and D, right? That's 0, 13, 2, and 20. $35 and 81 are very not related to one another. What's going on? Ooh, that's what's going on. So do we want the valve to check this? I think we do. So I think we want to say if self dot is open, then this else 0. Okay, and now the parsing doesn't work because because valve 9 is closed. So let's open it, I guess. Let's just say let me valve valves 9 dot clone. Valve dot open, and then this can become valve, and then we'll also assert that valves 2 get cumulative pressure from 0 is 0 because it's closed. Good. Good. Okay. So we can now organize our valves into a valve graph. Now we need to start working out how to actually run the algorithm. So the thing that's going to matter is that we need to be able to look up previous answers efficiently. And those answers are going to depend on some kind of valve state. Which is essentially going to be which valves are open, where the player is. I guess it's what time it is, where the player is, and which valves are open up to how far the player can actually go. It's interesting. As a side note, something in here reminds me of special relativity, where it's like you don't have enough, like the player only goes one space per minute, and so can't reach the other side of the screen if there's not enough time left, or the other side of the graph if there's not enough time left. It's kind of interesting. I feel like there's something analogous there. But anyway, so valve state, or valve graph state, I think is something we want. And we'll need it to be hashable, which should be fine. What do I want to test about it? Let's see. I want to say test valve graph generates state, and the idea here will be let's build a graph. And we can say graph.getState, let graph state be graph.getState, and it will be the state at time is 0 and the player is at AA. And the valves are what? I guess we just say which valves are open and which are closed. Interestingly, I'm not sure that vec is hashable. In fact, I think it's not. Let's see here. Let initial graph state be this. Let's let Let's do graph.open AA, and assert not equal initial graph state and graph.getState 0 AA. Oh wait, I don't need to tell you here which ones are open. That's already encoded. So that should be trivial. On the other hand, though, let final state, or let T29 state be graph.getState 29 AA, so our player's at AA. Let equivalent, let's say graph.open ZZ's not a thing, JJ, which is too far away to matter. And then we say assert equal initial T29 states and graph.getState 29 AA. Okay. And let's go T28 state and just check a more complicated case. Graph get state. So now AA and JJ are open. What does JJ connect to? II. So it shouldn't matter if like BB opens up or something. So 28 AA. Let's say graph.open BB, and then we assert that T28 state state 28 AA is the same because it doesn't matter that BB opened, they're equivalent. But if we graph.open JJ, no, JJ is already open, II, then it matters because we could walk from AA to II. So they're not equal anymore. Okay. Okay. Cool. So let's say valve graph, derive, a bunch of stuff, not default, yes, hash, clone and copy. I won't be able to because it, well, yeah, it can probably be copy. Let's find out. So this will be valve state. And the point is just to have a hashable thing that's equivalent if and only if they're equivalent situations. And we will say what? We will say player position is a string, time, so usize, t is fine, and valve states. We don't want this to be a vector because vectors aren't hashable. In fact, we might just want player position to be a usize. And now valve states. Can be a binary string, maybe? What's the best way to encode this? So certainly we could map it into the set of ones and zeros, like the number, the binary number that's associated with the set of ones and zeros, based on the ordering of the valves in the valve graph. And then as long as we can deterministically reduce that state when it doesn't matter, based on the time and the player position, which I think we can, because for each player position, for each time and player position combination, the only ones we ever care about are the digits within t of the player position, which is always a fixed number of digits. And so for t in player position, we can always say, okay, we're going to restrict our attention to these 5 bits if t is 2 and the player position is somewhere in the middle, and that's never ambiguous. So I think we just make this a U32. And then we impl valve state, pub function new, okay, and now the point is going to be that in here we're going to have get state. Let's put it up here somewhere. Which will take self, a t, a player position, which will be a string, and will return a valve state. And so t is already calculated. For player position, we need the index. So we want to say self.valves.get player position .expect. Player position should be a valid label. Oh, wait, that's not going to work. There's no defined order on a hash map. Okay, so I guess we just make it a string. But we still need to get here. We still need to know let valve be this, because this is complicated. We need to know all of the valves within T. And we need to get that in a deterministic way. Wonder if for now we don't bother. This is kind of an optimization. I thought it was going to be easy-ish, and it's actually a little bit tricky. So for now, let's just do we still would need a deterministic ordering. Which, I mean, I can sort it, but then we're going to be sorting over and over again, which I hate. We could keep some kind of defined order. But that seems kind of parochial. What's a nice way to do this? Because I don't think hash sets are hashable. I don't really think many collections are. Alright, well, maybe we do keep a predefined ordering around. Yeah, I guess let's just do that. So let's just do and what did I call the third thing? Valve states. Let valve states be self dot labels. Computing this kind of sucks. I don't know. Maybe, maybe not. I don't know. Let's see. I'm trying to over-optimize a little bit. And we just say self dot is open L, and we can unwrap because these should be guaranteed already. But then we want to turn this into a binary number, which we can do by saying fold, reduce, whichever one it is, I can never remember. I'll figure it out. But then this will be valve states. it will be valve state new T player position U32. And we should probably assert that player position, that self.valves, no, self.labels contains player position. We maybe will remove that during the, to make this a little more efficient, but for now, to avoid errors. Okay. And so now valve graph has to also have a list of the labels. Labels will be a vec of string and labels we'll say let labels be valves dot iter dot map ev dot get label dot collect. And labels contains player position. What's wrong with this? Expected reference. Do I need to T-string this? Okay. And this becomes what? This becomes dot reduce. Yeah, reduce. Accumulator element, and here we say what we want to left shift. So the accumulator is going to be, oh, it has to be fold, and this is 0. U32, and we do. We left shift it by 1. And we add the element as U32. Should work. And there should be valve states, and player position needs to be a string. No, it can be a label now. It can be the self dot. Let's get the index of the label then. Yeah. Maybe just make another hash map instead. Because otherwise I have to scan for the player position every time. So let's actually say get open. Get open indices, basically. Get open indices. And then we're going to take 0 and we're gonna add, we're gonna say AC. For each one, we're gonna add the element left shifted, no, 1 left shifted by the element. And similarly, we'll say let player index be player be self dot ordering player position. Expect player position should be a valid label. And then this will be player index, and we will turn labels into ordering, and it will be a hash map, and it will go from string to usize. And then this will go through the valves, and it will be get label I, where I is that. Self dot ordering should be dot get, and get open indices will be a vec of usize, and it'll be self dot ordering iter map label the number, and then self dot is we want to filter first. Filter self dot is open L. and then map I. And this is, we can just unwrap this. And that's the problem here. And we can just dereference that. Okay. And I think we also, in our new function, should check labels. Fine. Okay. So now we are folding what? This needs to be element as U32. Vec U size is not an iterator. Sure it is. No, it's not. Okay. And okay. All right. And so now we expect all our tests to be passing, except that some of the valve states should be failing, which is correct. And they're different based on their valve states, which is right. Okay. So do I want to say that I care? Let's comment those tests out for the moment. So we'll say, let's make these not equal at the moment. Let's make these not equal at the moment. Okay, so valve state is working. So now we just try to work backwards. So we started T as 29. We keep a hash map around. We check all the states, but there are a ton of states. Way too many, way more than we need. Okay, so I think actually we do care about these. It's going to be way more efficient to calculate distances than it is to run the algorithm for every possibility, even though a whole bunch of them are equivalent. So let's change this to get open indices within T of player position, let's say. And how to do that, let's say a function get open indices within self t is a usize, player position is a string, we return a pack of usize, we say let indices within be self.get indices within t, oh, it should really be distance, player position, and then we'll say self.get open indices filter I indices within contains I. And get indices within distance, size, player position, string, size. Let's actually give this as an index. Player index. And so then this can be a usize and player index. Player index usize. What to say here? Let distance, let mute distance remaining is distance. While distance remaining is greater than 0. Maybe I did want this to be the label. I think I do, because I want this to be self.valves.get player index .expect. Player position should be a valid label. So actually, this will be player position. String, oops, and same thing here. So we'll get it, we'll expect it. We will put it in a vec. Not valves though, labels. Ordering. put that in a vac. This should be player position. And then while distance remaining is greater than 0, we're going to say distance distance, so I got to finish up in a few minutes, -1. And let's do that, and we say let neighbors are self.get neighbors self player position. No. Now we need a mapping going the other way. Do we? No, I guess we don't. Let's actually not do this. Let's just say player position. And then for label into return, we can get neighbors of label. We can unwrap here. This is guaranteed to be fine. Can we push this onto just say to return dot append this, and then return to return dot into iter dot map l self dot ordering dot get l dot unwrap. Okay. And what's the issue? Sure, I'm gonna have to clone this anyway, right? Also, it needs to be deduplicated. So this maybe we collect as a hash set. And get neighbors we can union instead. And this can be get neighbors unwrap clone into iter dot collect as a hash sets. And then at the end, we have to collect. And Okay. And what's going on? One more failure somewhere here. Use of move value. Yeah, that's what I was concerned about. Implicit. That iter though. To return equals that. And expected a hash set, found a union. From iterator at string or reference, string reference. Sure, because what's get neighbors. Get neighbors returns an option. Clone into error. Hash set union dot cloned. Yeah, there it is. Can't assign to return because it's borrowed. Yeah, that's what I was worried about. Iter mute won't work. Okay. Unfortunately, I'm running out of time. So I think we'll start next time with fighting with the borrow checker here. We just need to... It's just one of these things where we're looping over a variable while doing things with the variable, and it's a little bit fidgety in Rust. So we'll straighten that out, at which point we will have... That means that we should have a way to identify state and compare state that will treat redundant cases, or like cases where the player can't reach a certain valve, as the same, which should give us all that we need to do to start compiling our map from states at t equals 29, 28, 27, 26, so on, to optimal moves. And that should be what we need in order to at least get an answer to the exam, at least make sure that everything is implemented correctly. I guess we might need to optimize a little more from there. But that's where we'll start. I probably won't be back tomorrow or Sunday because it's New Year's. So I'll be back on Monday probably. Hope everybody has a great New Year's, and I will catch you later. Take care.